Next topic is extreme values or maximum or minimum values. Extreme values means what? Maximum or minimum value. It is also called local maximum. There are words local maximum, local minimum. Okay. So extreme values means maximum value or minimum value is called extreme value, either maximum or minimum. So the first derivative test or the necessary condition for extreme value. So the question for 2 marks is what? State necessary condition for extreme of function of two variable. So if fxy is a function of two variable, has local maximum or minimum value at the point at the interior point AB of its domain. That is, this function fxy is either maximum or minimum at point AB. If fxab, then fxab is equal to 0 and fyab is equal to 0. So what is the necessary condition? If fxy is either maximum or minimum at the point AB, then fxab is equal to 0 and fyab is equal to, that is first order partial derivative at the point AB are 0. So this is the necessary condition for extreme value or maximum minimum value. Okay, that is, if the function is maximum or minimum at point AB, then its first order derivative with respect to x and y at that point is equal to 0. So this is the necessary condition. So this is the question for 2 marks, that state the necessary condition or state the first derivative test. So this is the first derivative test. Then second derivative test for extreme value. This is the first derivative test for extreme value. Now the second derivative test for extreme value, or is called sufficient condition for extreme value. So the question for 2 marks is what? State sufficient condition for extreme value or second derivative, state second derivative test for extreme values or for maximum and or minimum values. So this is the second derivative test, or it's called sufficient condition for extreme value or for maximum and minimum value. Suppose that the function fxy and its first and second partial derivatives are continuous, instead of this constant, right? Continuous throughout in the neighborhood of point EB, and fxab is equal to 0 and fyab is equal to 0. That is first order partial derivatives are 0. And if we denote if xxab, the value of second order derivative at point AB is equal to capital A, fxyab is capital B, fyyab is capital C, and delta, this is the notation delta, triangle, right? Triangle is delta, that is AC minus B square. Then fxy has local maximum or fxy is a maximum at point AB, local maximum or say maximum at AB, if delta is greater than 0, this delta is greater than 0 and A is less than 0. If A is less than 0, then and delta is greater than 0, then fxy has local maximum or maximum value at point AB. Then when fxy has a local minimum at point AB or local minimum value at point AB, if delta is greater than 0 and A is greater than 0, that is, if A is greater than 0, then value is minimum, and if A is less than 0, then value at that point is maximum. And fxy has saddle point at AB, that is the value, when we say the point is saddle point, if the point, if that at that point the value is neither maximum nor minimum, then the point is called saddle point. So when fxy has a saddle point at AB, or that is when fxy has neither minimum nor maximum at AB, if delta is less than 0, that is, if delta is less than 0, then at that point the function, the value of the function is neither maximum nor minimum. So fxy has a saddle point at AB if delta is less than 0, and if delta is exactly 0, then test fails. That is, this second order second derivative test, or is called sufficient condition, fails for that example. So if delta is greater than 0, then at that point the value is maximum or minimum depends on A. But if the delta is less than 0, then no need to check the sign of A. That the point is saddle point. And if delta is 0, then Also the no need to determine the sign. When we determine the sign or find the sign of a, capital A, if delta is greater than 0. So if delta is greater than 0, then the point, at that point the function is maximum or minimum. That's depend on A. If delta is greater than 0, A is less than 0, then at that point the function is maximum. And if A is greater than 0, then at that point the function is minimum. Okay, so this is the second derivative test, and this is useful to determine the values, maximum and minimum values of the function. So if the function is maximum or minimum at AB, then their first order derivative at point AB are 0. This is the necessary condition. And if we take the first order derivative and is equal to 0, and then the function is what, maximum, minimum, if these conditions are satisfied. So saddle point means the function is neither maximum or not minimum at that point. Okay, that is when the point where the function is neither maximum nor minimum, then the point is called saddle point. So for extreme value of the function, find the extreme values of the function. Question is what? Find the extreme values, or find the minimum and maximum values of the function, or find the local maximum and local minimum values of the function fxy is equal to obviously two variable function x into y plus 50 by x plus 20 by y. So this is the function fxy as x into y plus 50 by x plus 20 by y. Then the partial derivative with respect to x. So what is the procedure to find the maximum or minimum value? This is the procedure. That is, we consider as two equation fx is equal to 0 and fy is equal to 0, and solve these two equations simultaneously or independently, and find the values of the points AB. And the points are called critical points or stationary points. That is, after solving this equation, two equation fx is equal to 0 and fy is equal to 0, we have the critical points or stationary points. Okay, so what is the procedure? So first determine the first order derivative and second order derivative. Fx means f suffix x means partial derivative with respect to x. So derivative of x into y is y, and 50 by x, that 50 is constant, and the derivative of 1 by x is minus 1 by x square. So we have minus 50 by x square. Similarly, derivative with respect to y is what? X, and the derivative of this quantity is 0, and 20 by y, derivative minus 20 by y square. Then fxx, second order partial derivative with respect to x, y, derivative of y is 0, minus 50 is constant, and derivative x divided by x square means x raised to minus 2. And its derivative is what? By using x raised to n minus 2, x raised to minus 2 minus 1 means minus 3. And that is, we have the answer 100 by x cube. Then fxy means what? The derivative of fx with respect to y. The derivative of fx with respect to y, or the derivative of fy with respect to x. The derivative of fy with respect to x. So the answer is 1. Fxy means what? The derivative of fx with respect to y is 1. Then fyy. What is fyy? Fyy means the derivative of fy with respect to y, derivative of x is 0. And then minus 20 as a constant, divided by y square means y raised to minus 2. Its derivative is minus 2, y raised to minus 2 minus 1, that is minus 3. So we get the answer 40 into y raised to minus 3 means 40 by y cube. So for stationary points or for critical points, consider the equation fx is equal to 0 and fy is equal to 0. That is, after solving these two equations simultaneously or independently, that is by adding, subtracting, multiplying these equations, we have the critical points or stationary points. So for stationary points or critical points, consider the equation fx is equal to 0 and fy is equal to 0. So fx is this and fy is this, is equal to 0. So from equation number 1, y is 50 by x square. Substitute this equation in equation 2, y is equal to 50 by x square bracket square. That is 50 square is 20, 22 pi double to 0, and x square is x raised to 4. And then this x square shifted to the numerator. So x square divided by x raised to 4 divided by this 250 by 2. 0 get cancelled. So we have the answer 125. Okay, 2 by 250, 20 by 250, 00 get cancelled. 2 by 250 means 1 by 1 by 1 2 5. Okay, so take x as common. So 1 minus x cube by 125, that is x is 0 or this bracket is 0. And so x is 0 or this bracket is 0 means 1 is equal to x cube by 125, that is 125 is equal to x cube, means x is 5. Okay, because 5 cube is 125. And so if x is 5, then y is what? Y is x. If you substitute x is equal to 5 in equation 1 or 2, either substitute in equation 1 or 2, so this y minus 50 by x square, that is 25, and that is y is 2. Okay, so either substitute x is equal to 5 in equation number 1 or 2, but if you substitute x is equal to 0, x is equal to 0 in this equation, then we have 50 by 0 square means it's infinity, y is infinity, that is indeterminate form. So x is equal to 0 is not the value. We can use the value, just substitute x is equal to 5, we have y is equal to 2, and therefore stationary point is what? 5 2. 5 x, value of 5 x is 5, y is 2. So 5 2 is only one stationary point or critical point. This point is called critical point or stationary points. So there is question for 2 marks, that instead of this find extreme value, the question is what? Find critical value, points, or find stationary point of the function. So the points where the function may be maximum or minimum is called stationary point, either minimum or maximum, or the point is saddle point. So after solving these two equations, fx is equal to 0 and fy is equal to 0, we get stationary points or critical points. So in this example, we get only one critical points. So in some examples, we get 2 or more than 2, that is 3, 5, 4, 5, 10 critical points, or 15 critical points. Okay, so in this example, we have only one critical point. So nature of the function at that point, number 1 at point 52. So when the function, how we can determine the nature of the function? So fx is equal to 0 and fy is equal to 0 gives the stationary point. Now find value of capital A, capital B, capital C, and delta. So what is capital A? F x x x at the point 52, right? The in bracket 52. So f x x x 52. That is substitute in the function, in the function f x x is this 100 by x cube. Substitute x as 5, y as 2. So we get x as 5, y as 2. So we get 100 by 5 cube. X is 5. So 100 by 125, that is 0.8. Then capital B fxy 5 2, value at 5 2. Fxy is 1. So at the value at 5 2 is also 1, fxy. Then C is fyy 5 2. C is what? The value of C means the value of fyy at the point 5 2. So fyy is what? This fyy is the value of fyy is 40 by y cube. Substitute y as 2. So 40 by 2 cube, that is 40 by 8. C is what? 40 by 8. Yes, C is 40 by 8, that is 5. And then delta is AC minus B square, A into C. A is 0.8, C is 5 minus 1 square, B is 1. So 4 minus 1, that is 3, and is greater than 0. And so what we have? Delta is greater than 0. And what is the sign of A? A is greater than 0. And so the fxy has a local minimum value at 5 2 because of this sufficient condition. That fxy, if delta is greater than 0 and A is also greater than 0, then at that point the function is minimum, has local minimum value at the point AB, or the function is minimum at the point AB. So fxy has a local minimum value at 5 2 because delta is greater than 0 and A is greater than 0. And the minimum value of the function is what? F of 5 2. That is the find the value of the function fxy at 5 2. That is substitute x as 5, y as 2. And so we have f of 5 2 value is what? Substitute f of xy is this x into y. 50 by x plus 20 by y. Substitute x as 5, y as 2. So 5 into 2, 10, 50 by 5, 20 by 2. 50 by 5, 20 by 2. and that is 10 plus 10 plus 10, 30 is the answer. So this is the minimum value of the function. So this function has only one value, minimum value. Okay, that is the function is not maximum anywhere. The function has only minimum value. The function has no maximum value. The next is find critical points. That is just find critical points or stationary point of the function. X raised to 4 plus y raised to 4 plus 4xy. So fxy is this function. So in order to find critical points, no need to find the second order partial derivative. If we were to find the extreme value of the function, then find second order partial derivatives. Otherwise, no need to find the. In order to find critical points or stationary points, just find the first order partial derivative. That is fx is equal to this 4x cube y raised to 4 derivative with respect to x of y raised to 4 is 0, and this is 4y, and this is fy is what 4 fy is what 4y cube. Yeah, right, 4y cube plus the derivative of this 4xy with respect to y is 4x. Then for critical points, consider the equation fx is equal to 0 and fy is equal to, that is this is equal to 0 and this is equal to 0. Okay, so subtracting these two equations, add these two equations, or multiply, divide these two equations, or find the value of x or y from first equation, substitute in second, or find the value of x or y from second equation, substitute in one. So we can solve these two equations simultaneously or independently and find the values of x and y. So here y is equal to, from equation number 1, y is equal to minus x cube. Substitute in the equation 2 as y as x minus x cube plus 4x is equal to 0. That is minus x raised to 9 minus x raised to 3 raised to 3 is what? X raised to 3 into 3, that is minus x raised to, and the third power, odd power of negative value is negative. That's why minus sign. X raised to 9, 4 get cancelled. X is equal to 0. Take x as common. So we have minus x raised to 8 plus 1 is equal to 0. So x is equal to 0 or minus x raised to 8 plus 1 is equal to 0 means x raised to 8 is 1, means x is 1. Okay. So x is 0, then y is 0. If we substitute x as 0 in this equation, in any one equation, that is either in equation 1 or in equation 2, if we substitute x is equal to 0, then we have y is also 0. And so and if we substitute x is equal to 1, then in equation, either in equation number 1 or 2, x is equal to 1, then y is minus 1. Y is minus 1. If we substitute x as 1, so here we have minus 4 plus 4. By shifting it to right side, it is minus 4. 4y is equal to minus 4, means y is minus 1. Okay, and so the critical points are 0 0. If x is 0, then y is 0. And another critical point is what? Stationary point is x is 1, y is 1, minus 1. Then 1 minus 1 is another critical point or stationary points. So here for this example, there are two critical points, stationary points. And in order to determine the extreme values, if the question is, instead of this question is find the extreme values, then find the second order partial derivatives, fxx, fxy, fyx, and then find the values of capital A, capital B, capital C, and delta at the point 0 0, and at the point 1 minus 1 we have the nature of the function. Find the extreme value of the function fxy is equal to x raised to 4 plus y raised to 4 plus 4xy, the same problem. Okay, so first find first order partial derivatives, then second order partial derivatives, and then consider the equation fx is equal to 0 and fy is equal to 0 for critical points. Find the critical points. Already half problem of the answer of the half problem is as above. And then find second order partial derivatives. This is 12x square fxx, that is this derivative of this 4y 0 with respect to x. Then fxy means what? Derivative of fx with respect to y. Fx with respect to y is 4. And then fyy means the derivative of fy with respect to y. Derivative of 4x is 0. This is 12x square. Then nature of the function. There are 2 points, critical points. So number 1 at point 0 0. Nature of the function at point 0 0. So find capital A. Capital A means fxxx at 0 0. The value of fxx at 0 0 means the substitute x as x is equal to 0 and y is equal to 0. Then we have the answer 0. Capital B is what? Fxy at 0 0 is 4. And fyy at 0 0 is again 0. And then delta is AC minus B square, 0 into 0 minus 4 square, that is minus 16 answer. And is less than 0 means 0, 0 is saddle point. That is the function is neither maximum nor minimum at 0, 0. And then the nature of the function at the point number 2, at the point 1 minus 1. Then capital A, fxx at a 1 minus 1, fxx is this, substitute x as minus 1, x as 1 and y as minus 1. We have the answer 12. Fxy at 1 minus 1 is 4 and fyy at 1 minus 1. So fyy is 12 y square. Substitute y as minus 1, but minus 1 square is plus 1. So we have the answer 12. And then delta is AC minus B square. 12 into 12 minus 4 square. That is 144 minus 16. That is 128 is greater than 0. And so delta is greater than 0 and A is also greater than 0. And therefore the function fxy has local minimum value at 1 minus 1, or the function has minimum value at 1 minus 1. And the minimum value of the function fxy is what? F of 1 minus 1. Find the value of the function at 1 minus 1, because at the point 1 minus 1 this function is minimum. So the minimum value of fxy is 1, f of 1 minus 1. That is, find the value at 1 minus 1 of the function. So substitute x as 1, y as minus 1. We have the answer minus 2. And this is the minimum value of the function. The function has no maximum value. Okay. So these are some problems of the extreme values. So we will discuss the remaining problems in the next lecture.